Hi guys, welcome back to Future Dimensions 360. So finally, we are going to start a new tutorial series related to Git and GitHub. This is the first lecture. In this, we will be learning about a little bit introduction and some version control system and why Git is required in current era of a programmer. So let's move forward and try to learn some examples in which we will be explaining why a version control system is required. Git is actually a version control system. We'll be learning that later on. But firstly, I want you guys to understand what is version control system and why it is required as a programmer, why you need it. So let's go ahead and let's say there is a software in which you have a couple of features. Let's say feature A, feature B, and feature C. You will be having like couple of features. So a big software will have a lot of features. Let's assume you have 3 features and you have a developer who is working on these features and he is communicating with the customer because all the software that is a requirement of a customer actually. For example, let's say in feature A, customer said that I want some specific features and developer has implemented those features. Once it's done, he will tell the customer that please review the build. These features are done, or like feature A is done, please have a look into it. Customer said like I don't want this feature or I want to add something more in that one. Please implement that. Developer will implement the feature B and he will show to customer that this is the feature B what you had told me with some specific requirement against feature A. Have a look into it. Customer will say okay, that's true, but I want something more on top of it. Now he will tell you something. A developer will implement something on feature B and the software will turn to feature C. He will show it to the customer and then the customer will say again same thing like okay, whatever you had implemented is correct up to mark, but as per my scenario I want feature A. That developer has implemented 2 steps back already. But what happened here is when developer is updating his program, he had updated the program already, then kept a copy of his old code that customer seen in feature A build. So he don't have any kind of build. So keeping the copy of build, for that one we need version control system. This is the first problem. Like there is no versioning. Like customer told you to implement something. As a developer, you implemented and you override with new features, but you haven't kept a copy of your old program. Let's say there is another software with feature A, B, and C. There are 3 different developers working on each feature. Developer A working on feature A, developer B is working on feature B, developer C is working on feature C. Ultimately, what will happen? These all features need to be merged in a single software. When you want to merge these all code, it's very normal that many developers will keep the classes name same, keep the functional name same, keep the variable name same. So those similar name will create conflict between their codes. So when you will copy the code in the same place, it will create a problem when you want to run the software. It will give you an error of duplicate class name, duplicate feature name, duplicate variable name, or any XYZ thing. So you don't have any proper way to merge or track the conflicts of multiple modules that is being built by multiple developers. For that one, you need a version control system as well. Lastly, let's say a team of 3 developers are working already in an existing software, but there is another junior developer they hired. He came. What he will do is he will copy the code from the central or single software and do some changes in that. He's a junior software developer and he had done some mistakes in that. Once he will copy the code in the single software back again, you guys will face an error or developers will face an error. Ultimately, they will not know that which developer have done that mistake because the code is already overridden by the new developer or the junior developer. So keeping track on each file which developer has changed, you need again version control system also. So these are the 3 main problems. For that you will be needing what? Version control system. So first of all is versioning, keeping the track of your build, or keeping the copy of your build. Secondly, merging. You have to merge the code. You can say you have to merge the code intelligently, that you will keep track on duplicate classes name, variable names, or duplicate code or duplicate features, so you can merge them in a way that you can resolve the code immediately when you are overriding it into the single software. Lastly, you want to keep track on each file, that this file is being changed by which developer and when and what time, and what are the codes lines he had changed. So for that one, we need version control system. How many version control systems are available until today? There are two types of normal version control systems are available. One of them is centralized version control system that was used before earlier. There are some problems in that, and then a lot of companies, they had launched a distributed version control system. First of all, what we will do is we will learn the actual functionality of centralized version control system, and then we will find out the problem in that, and then I will explain you about distributed version control system. Let's say centralized version control system, how it works. There are three developers, developer A, developer B, and developer C. Everyone is working in their PCs. Like they will have their folder called working copy of their software in their PCs. And there is one centralized repository in which they will be sending the code. As soon as developer A had done some features, he will he will just commit the code in centralized version control system, copying the code from working directory to the centralized repository. The functionality is named as commit. He will commit the code where in the centralized repository, and then he will take a checkout to check out if, for example, let's say there are some features already available in centralized repository. He will be checking out those features in his local machine as well. So he wants to check take the copy of existing software or check the feature of any developer B or C. So he will be checking out. Similarly, developer B will be doing the same thing, and developer C will be doing the same thing. So this centralized repository is actually available on network. You will be requiring the network, or each developer will require the network to push the code or to commit the code from his local workspace to the centralized repository. Let's say if he don't have any network connection, or if the remote repository is down, what will happen? What will happen in that scenario? Or let's say he don't want all the code that is available in repository or centralized or remote repository. He wants some specific piece of code or some specific module. Or let's say a manager assigned him some features and he wants to get the code for those specific features only. How you can deal with that? Already developer A, B, and C, they are just passing the code to the centralized repository where you are maintaining the versions, where you are merging the code intelligently, where you are keeping the track which developer is shared. But there is no way to get some specific modules, or there is no way to handle these scenarios if the repository is down or if there is no network connection. So overcoming these problems, there is one version control system that is known as centralized version control system in the market, named as SVN. So on top of these problems, there is another version control system came into the market that is named as distributive version control system. How it works? Let me explain you guys how it works. Let's say there is developer A, and each developer is keeping his workspace in his PC along with the local repository in his PC as well. If any of you guys had worked already with Git, you will be knowing that whenever you will initialize the Git, there is one .git folder that is created automatically in your project. That is actually responsible for the local repository. So each developer, whenever he will change anything in his code, will commit the code instead of remote repository to his local PC repository. And if he wants to check out anything or check out the code of any developer, he will be getting checkout, or he will be using checkout command to check out the code of any developer locally in his repository. Similarly, other developer will be developer B will be doing the same thing, and developer C will be doing the same thing as well, performing the similar actions within their PC. Developer A is nothing but just a working repository, and local repository working copy or workspace, and there is each developer will have their own local repository within their PC. Now, anytime they want to commit the code, whenever they got network access, if in case they don't have network access, that doesn't matter, they will keep the record of local repository. Or in case developer C had worked with developer A on specific modules, developer B don't need those modules, so he will not be getting the code of their branches. Like each developer will pushing the code to the remote repository by using network with push request on specific branch. And at the end of the day, all those branches should be merged on one single branch, either named as staging branch or master branch, or some people they are using main branch as well. So if developer A needs some specific module code and developer C had worked on that module named as ABC branch, so he can check out that branch in his local repository only. He don't need to get the code for developer B. So like this way you can just get the code of each module in your local PCs and will be maintained by your local repository against the remote repository. On the other hand, remote repository will keep track on each branch or each module or full project inside it, and at the end of the day or ultimately each developer will push their local repository code towards the remote repository by using network. This is how you can put your code in the one centralized system. In case you don't have network or your system is down, what you will be doing, you will be keeping track of your files in your local repository, or local repository is responsible for keeping track of changes. As soon as you will get the network back, you can push the code into the remote repository, and this remote repository have the ability to create versioning, to create branches, to keep track on each file what developers has changed and which module and which file they had changed. And lastly, it will allow you to merge the code intelligently by using merge branches and by using merge command, and a lot of commands are available. We will be discussing that later on in our coming series. So let's say how many distributive control versions are available in the market. The biggest one and last normally people they are using is Git. We will be learning in this tutorial series Git. Other than that, there is Bitbucket available, then GitLab is available, AWS Code Commit is available, Apache subversions are available, and then Helix core is available, and Unity control version. There are some more with distributive version control systems are available there as well, but we will be learning in this tutorial series Git and GitHub. So in the coming tutorial, I will be letting you guys understand the actual architecture of Git and what is Git. So stay tuned. I'll see you in the next video. Please don't forget to subscribe and like our channel. Until then, take care. Goodbye.